Welcome to the TechShift F9 podcast, where we talk about career transitions and pivots in the age of technology with amazing guests who share their incredible career journeys, hacks, and experiences. I am Maurizio Rafone, your host, and can't wait to get started. Today we have one of our deep dive episodes where we explore a particular career with a renowned professional and hopefully provide helpful insight as to what that profession is like. Today we speak with Marko Simic. Marko is the former Chief Technology Officer at Ascent Robotics, a leading provider of intelligent solutions for industrial robotics and autonomous mobility. Marko is an artificial intelligence and machine learning specialist, and we'll deep dive with him what it's like to be a senior software engineer in the exciting space of AI. Hi Marko, welcome to the TechShift F9, the deep dive episode. I really appreciate you being here today.
Hi, thank you for the invitation.
Well, why don't we start with you telling us a little bit about your journey in the field of artificial intelligence and how you became a senior software engineer in this domain.
Yeah, sounds good. My journey started indirectly. I studied mechanical engineering back in school, and my first exposure to machine learning and neural networks was maybe 2008 or something like that. And if I'm being honest, I was just like, okay, I don't know what this is. I don't like it. So my career went into a different direction. But around 2013, I came across a book called On Intelligence from Jeff Hawkins. Jeff is a guy who came up with Palm Pilot and Trio, those devices, right? But then he switched to neuroscience, and he wrote this book on intelligence. I read it, and that was like a pivotal moment for me. I realized that AI is an exciting technology. It holds promise to improve literally everything, or maybe destroy everything, but time will tell.
We'll get to that.
Yeah. So at that moment, I basically decided to shift my career from mechanical engineering to AI. And at the time, I was still in Serbia. However, the tech sector in Serbia, and especially opportunities with machine learning and AI, were almost non-existent at that time. So I had to leave the country to pursue my dream. And spent some time in Russia, some time in US, and then landed in Japan. And that's how I got into AI.
And in terms of the specific areas of artificial intelligence that you're specialized in, can you tell us a little bit about that and perhaps some projects that you've worked on that you're very proud of?
Yeah, sure. So AI, as you know, is a very general and broad term. It includes many different subdomains. So one of the subdomains is machine learning, which is what I specialized in. And even more specifically, it's primarily deep neural networks and deep learning. So I focused on that part, although both machine learning and AI are much broader. And when it comes to the actual applications, I used machine learning and deep learning for a variety of different problems and domains, from computer vision to time series, tabular data, reinforcement learning for robotics, now language and NLP. So the good thing about deep learning is that the building blocks are the same for any domain, basically, right? So if you have that foundational knowledge, you can apply it to different domains.
Okay, and so machine learning isn't just regression analysis, is it?
No, so
It's
machine learning.
Don't be offended.
No.
We'll go into deeper discussion of different areas of AI and specifically what you're doing. But in terms of your job as an AI engineer, what's a typical day, or week, or month for you?
Sure. So first, it depends on both the company you're working for and what exactly we mean by AI engineer. So some AI engineers work mostly on the novel models, so researching and coming up with new neural network models or some other machine learning models to solve problems, while some other AI engineers are working more on the full stack deployment, machine ML ops, and things like that. So it will depend. There is no like one size fit all, I would say. In my background and experience is mostly in the model development and training of novel neural networks to solve problems. The job entails all the same things as regular software engineering. It's just that we have that additional, well, burden, let's call it burden, of dealing with neural networks, right? The crucial point is always to understand the problem and the context and the objectives, because without that you'll just end up with the solution that's probably not right for the problem, right? So yeah, when you have a problem to solve, first we need to try to understand the context, the actual objectives, and like business goals, and based on that, we then try to come up with a solution.
Totally makes sense, but I want to dig a little bit deeper into that because you're a specialist in deep learning and neural networks, and I see a lot of software engineering that is very practical. I mean, not a lot of thinking. There's a lot of doing, and I know I'm being a little bit extreme, but my impression with your expertise, deep learning, neural networks, there's a lot of thinking, a lot of research, a lot of just brain power that needs to be put on what to do rather than just jumping into coding and programming. Is this right? Or do you have different subcategorization of people that specialize on the theory and you guys focus more on the practice?
So I would say it's partially right. All software engineering entails thinking about the architecture and decisions you're making, technical decisions you're making. So we're not different in that way. And the best practice is actually to first, when it comes to machine learning and deep learning, is to first figure out if anybody else solved this problem already and if there are already ready-made solutions that you can utilize, because there is no need in like inventing the wheel again if the solution is already out. So first start with what is available, test that. If it's good, then great, your problem is solved. And then if it's not good, then try to improve it and figure out how to solve the problem. In some cases, it turns out that there's no need for any like neural network or machine learning, right? You can solve the problems in different ways. And when it comes to research, yeah, that will be the last step. So if there is no solution for your problem, sure, then let's try to figure out how we can come up with new architectures with maybe some new loss functions and layers, so we can improve the models and solve the problem. But I would say that that's the last step in the engineering effort. If you're doing your PhD, then it's different. Then
Right,
your job is actually to come up with the novel methods.
And so, if we were to frame the primary responsibilities that you have when working on AI projects, of course, at your level, which is CTO of a company, senior level, beside programming, what is something that takes most of your time, or if you could rank it in terms of your focus and responsibilities?
CTO role depends on the company size and stage. So if the company is at an earlier stage and the team is smaller, you'll be doing more hands-on work and actually building the solution. On the other hand, if the company is quite large and the team is very big, then probably you'll be doing more of management work, right? Both things have pros and cons. Some people prefer one, some people prefer the other. For me, it depends on the day, I would say. On the management side, again, you'll probably be doing some engineering management, basically enabling your team to work as efficiently as possible, removing blockers for them so they can work well, resolving conflicts between people. That happens all the time, unfortunately.
Of course.
You'll be doing some product management, most likely too, discussing and negotiating with all stakeholders what the product should actually be. And then also you'll have the technical discussions about the architecture with your tech team. And I think that as you rise in the seniority from the individual contributor to the executive level, the amount of managerial work increases.
Of course. But so I get the impression that working in the AI sector isn't all that different from a lot of the other tech sectors. Is that a fair assessment?
That is a fair assessment. I think that, especially now, it's pretty much software engineering with the addition of like some machine learning modeling. But yeah, most of it is actually software engineering. And in order to be a good machine learning engineer, you need to be a good software engineer.
Absolutely. What programming languages and frameworks do you typically use in your AI projects, and why are they your preferred choices?
Well, I prefer Python, and it's basically an industry standard, if I'm being honest. I don't know why exactly that happened, but probably has to do something with Python's easy syntax and like flexibility. So it's easy to prototype in it and build something. So most of the machine learning field and AI field is actually working with Python. Although we have pretty good libraries in other languages like JavaScript, C++, and some in Swift too. Julia is also a popular choice for some data science. But yeah, for me personally, it's mostly Python. In terms of framework, that changed through time. I started with something called Café, which was like an old school framework. Then transitioned to TensorFlow when it came out, then to PyTorch, and I'm still mostly using PyTorch, but TensorFlow is still popular. JAX is also quite popular nowadays. And another excellent high-level library that people are using is Keras. So yeah, I would say right now it's PyTorch, TensorFlow, Keras, and JAX. In terms of capabilities, they're very similar. There are differences, obviously, but yeah, it's for most people, they'll do the job.
On that point, AI and machine learning technologies are constantly evolving, and the frameworks have changed. Okay, maybe the core programming language hasn't, but it might. So, in your role, how do you stay up to date with the latest advancements in the field?
Twitter. Obviously, you need to follow the right people, right? So you need to manage your Twitter feed to get the right information. And other than that, it's just archive, which is basically a repository of new research papers, not just in machine learning, but in computer science in general. YouTube, there's a lot of YouTubers who post machine learning content. And then also conferences. So most machine learning and AI work is first published in conferences opposed to the journals, right? So conferences like ICML, NeurIPS, and similar are usually, not usually, but they're an excellent source of new research. So Twitter, YouTube, archive, and conferences.
Okay, that doesn't sound so hard, and now I understand why you don't follow me on Twitter.
So it's, in terms of sources, it's not that hard, but a lot of people are working in this field now, and there's a lot of output. So
a lot of noise.
Yeah, exactly, and it's easy to feel left out and like, oh no, I'm falling behind, right? So much research that I have to follow, like this in NLP, this in computer vision, this is reinforcement learning. How can I catch up with everything? But yeah, you deal with it. And after all, you don't have to know everything.
Of course, but I can see that you're making a concrete effort to make sure that you are staying on top of things. And I think that's a natural need for this kind of highly technical job. You just can't sit back and do the job. You have to update yourself.
That's for sure.
And switching gear a little bit, talking about your experience maybe more on the managerial side, when starting a new AI project, do you have an approach in terms of the steps that you take to understand the problem and design an effective solution? I mean, over the years, you must have done a number of projects, and so what's that learning taught you about how to approach it?
Yeah, so the most important part is to understand the problem and context. So depends how you're given the project, but like you need to talk with all the stakeholders to completely understand the context and what exactly they need. Not so much what exactly they want. Those are different things. But yeah, what is exactly the problem? And when you understand that, you can start working on it. And it's also crucial to keep all the stakeholders in the loop and have a two-way conversation because things are changing. You get new experiment results that can change your thinking and can influence the project direction. So you need to communicate well the progress. Once you understand the problem space and know what you need to build, and if that entails building a machine learning system, the first step would be to see what data is available for you, because most machine learning systems require a lot of data. Not all, but usually you need a fair amount of data. So figure out how to get the data, and if it's available in the first place. If it's not available, then there are methods to even create it. That's something, for example, what we did at Ascent. We built a robotic solution that had a perception module that relied on neural networks, but we didn't want to collect real-world data from factories and from our customers. So we built a simulator to generate synthetic data, right? And in that way, we didn't have to do any manual labeling and data collection. We just generate synthetic images and use that to train the models. So understanding the problem, collecting the data, right data, cleaning the data, doing some basic data analysis on it to figure out, especially if it's like tabular data or the time series, just check the basic statistics stuff and see if there are some outliers, something is off. When you're fairly confident in your data, then you can start modeling. Usually start modeling basic solutions, establish some basic level, and then go from there, iterate from there. Just prototype fast, build something that works, have a baseline, and then benchmark based on that baseline. And yeah, machine learning training involves a lot of iteration. So
Right.
you'll iterate on data, you'll iterate on your models. So you'll have to have a good way to track all of your experiments and also to version your data, right? So you know which models were trained on which data. And you also need to have a very robust evaluation pipeline or evaluation process. Does that answer the question?
It does. I mean, you've basically walked us through the typical workflow of an AI project. I was wondering, what would be the typical timeline by the different steps? The data acquisition, the pre-processing, the model development. Just big picture, maybe on one of the projects you worked on, just to give people an idea of what it's like.
Again, there's no like general statement. It's just that sometimes you work with small models, easy models that you can train in an hour or minutes. So So training is quick, but then it takes a lot of time to collect and clean the data. But on the other hand, you can have projects in which it takes days, weeks, and even months to train the models.
So, for example, if you are evaluating a project at the very early stage, you're sort of already thinking about how long it would take, what the required resources in order to efficiently do it, and also, I suppose, have a cost element and a profit element, right? The business side of things. So when you look at a new project, perhaps you could share with us what are some of the key items that you look out for that could give you a sense of just how difficult or time-consuming that could be, or exciting, perhaps.
When it comes to allocating time for projects, I would still allocate most of the time for model development and iteration. And these are not like static categories. So it's not like, oh, you collected the data and now that part is done, right? You'll most likely have to just iterate both on data, both on the models and on your evaluation pipeline, right? So it's not like, okay, I'm done with data, now we do this, and now we do evaluation at the end. So you'll always be working on understanding the project, improving your data, improving your models, and fixing your evaluation pipeline and deployment pipeline. But in most projects, I would say that developing a new model and training a new model takes majority of time.
Understood.
Yeah, and then in terms of some other things to consider, is like, okay, availability of data is one thing. Your compute is another thing, right? So if you don't have access to good hardware, maybe you can't actually create big models, and you have to rely on smaller models that you can actually train. Then deployment is also a big question. How is the model going to be used? Is it like something that runs on the embedded hardware, like in robotics, or is it something that has to be available to like millions of people, like ChatGPT, right? All those things have different requirements and impact the project in a different way.
And with regards to this interconnected evolution of an AI project where, as you said, the data needs to be constantly evaluated and models and so forth, does that put an extra pressure onus on the people in different teams to be able to work very effectively with one another?
One thing that we noticed at Ascent, for example, is that non-machine learning engineering, just regular engineering, software engineering, is more deterministic, and you can evaluate the required time a little bit better. Although the time estimates are always tricky and prone to to mistakes, when it comes to machine learning, it's even worse, right?
Oh,
So
gosh.
yeah, unfortunately, and it can happen that, okay, we think that we'll be able to build and train this model like in a week or 2 weeks, but it turns out something is just not working, right? So you need to have that good communication with the rest of the team, and sometimes you can be a blocker, but hopefully you structure your project in such a way that that other people can build around you, right? And then at the end you can just plug your solution.
Marko, data is a critical component of AI models. You mentioned it a little bit earlier, and you also alluded to some of the challenges. But can you perhaps expand a little bit more on what are some of the challenges that you often face when dealing with data, and how do you ensure that data is actually of high quality and representative of real-world scenarios?
Yeah, data is crucial for machine learning, as people usually say, garbage in, garbage out, right? So if your data is bad, your machine learning model will be bad, and there's nothing you can do about it. So you do need to ensure that you have access to good data. How you do that is you buy it, you manually collect it, or you create it, right? And in each of those instances, you need to ensure that the data that you obtained is valid data and a good representation of the data your solution will encounter in real life, right? Because if you have clean data, but it's slightly different distribution than what your model will see in practice, then again, your model will not perform well in practice. So we had, for example, a situation again, in my previous work when even though we were generating our own data, synthetic data, and that should be we can basically change everything about it, right? Because we control it. At some point, the networks were not learning well, and so we were puzzled what's happening. And what was happening was that the labels that we were generating were just wrong. So it was related with like object detection in space. It turns out that how we index the edges of the objects was different than what we assumed, even though we created the simulator, right? So we lost, I don't know how much time on just figuring out, okay, we screwed the labels, right? So you have to be very mindful. And it always helps to manually examine the data. For example, if you have images, always try to visualize your data, visualize the labels, just confirm that everything is as it should be. Besides that, there's also just cleaning the data. If you have like a lot of tabular data or time series, you want to maybe remove the outliers, remove the noise, just do the basic data science pre-processing. You want to version your data too, because as we mentioned, as you go through the project, you iterate through the models and through your data, and you want to know what data was used for what experiment. That's very important because like when you come back to your model like 2 months after, you want to know exactly what data was used, and you don't want to guess or like do something unexpected. And another thing that happens is domain drift in production. So for example, let's say you collected good data, representative data of real world, and you train the model and it performs well, and you deploy the model in production. But then real world is noisy, it changes all the time. So as the time progresses, the real data distribution changes a little bit, right? And so you can experience the drop in the model performance, and you'll like, oh, why is this happening right now? Model is the same, right? But what changed was the real data. So you need to refresh your data and then retrain again.
It's very insightful. I like the fact that you've pointed out how important that still a human action is performed to make sure the data works. Because a lot of people, I think that data is a black hole, and we don't know what's going on. But there's still a lot of people actually eyeballing data and eyeballing the, as you said, the continuous change to the real world variables that drive that data. And that brings the next question, which is about bias. Right? Bias in AI models has become a significant concern. There's a lot of talk about potentially having issues with how the AI models behave because of potential bias in the data. So, in your experience, how do you address or mitigate bias in AI systems that you work with?
So there's a lot of focus on bias nowadays and in the media, right? But as you said, it's nothing new. We had to deal with that since the beginning, and you just use the some of the methods that we talked about earlier, like examining the data, pre-processing, cleaning the data. Sometimes you have the unbalanced data. You have, for example, a lot more representation of class A compared to class B, so you want to balance that out. But then again, also sometimes bias is not just in the data, it's in the real world, right? Real world is biased, and oftentimes data just reflects the real world. So you have to decide what's important for you, to have a more neutral model or to have a model that reflects the real world better. I think that in computer vision, it's a bit easier to deal with bias because you can see it.
Right.
You can visualize the images. When it comes to natural language, especially these giant models that are trained on terabytes of data, then it's very hard. And you mentioned previously that some of the data sets that we use are like black holes, and that's actually true, because nobody went line by line through all the trillions of data points that large language models are trained on. So who knows what's contained in the data, right? And that is an issue, and people are raising that issue, and other people are working to solve that problem.
And so exactly on that point, Marko, can you explain perhaps a little bit the role of large language models in AI and how that impacted the field and your work?
Yeah. So natural language processing is a old field, same as computer vision, right? But with the invention of transformers, I think that was 2017, if I'm not mistaken. Maybe I'm wrong. It doesn't matter. With the invention of transformers, and it entered its renaissance, the same way that computer vision exploded with AlexNet and ImageNet. The same thing happened with transformers and natural language processing. And what these large language models that are all basically based on transformer architecture allow us is to have better conversational interfaces. Then they allow computer systems to use human language almost on the same level as humans. The philosophical question is if these models actually understand the language, or they're just like statistical pattern matching machines. But for the most of the people, the important part is that they can use them in their in their products and in their systems.
And Marko, talking a little bit about a topic that I'm very passionate about, money. AI projects can be computationally expensive, right? I mean, you mentioned that point earlier. So, as a CTO, how do you optimize AI models to balance performance and resource utilization?
Yeah, uh, it is an interesting question. There are a couple of options when it comes to machine learning. Obviously, you can try to develop and train your models on your personal machines like laptops and desktop stations, but that will only take you so far, because most of the models nowadays can't fit well on one GPU, right? So then the next step is to either build an in-house server farm, or just utilize one of the cloud providers like Amazon and Microsoft and Google. The cost benefit analysis on on-premise and cloud compute is dependent on the company situation. So for some companies, it will be better to use cloud. For some other, it will be better to use on-premise. And actually, quite recently, maybe a few months ago, there was a lot of discussion about moving away from cloud to like on-premise compute. Any project has its budget, right? And you have to balance the people, salary, compute, and other expandable things, and then figure out what is the best approach for your company and your project. In most companies that I worked for, we had a hybrid approach. Basically, we had some amount of on-premise compute, like GPUs and GPU servers, and then we would also supplement that with cloud. But nowadays, especially with large language models, cloud seems to be the way to do it, because they require a lot of GPUs to train.
Right. And is there an inflationary approach perhaps to AI, they were saying, with basically becoming the domain of only a few because it's becoming more expensive, it's becoming more challenging? whilst at the same time AI is being sold as a technology that should be more inclusive because everyone can access a high ability of computer power and computer thinking. So these two elements to me sound a little bit like conflicting with each other. What's your view on that?
And that's also not a new discussion. We had the same thing with computer vision too. People were concerned that large companies like Google and Facebook are just hiring all the PhD students and professors, and they have access to all the compute, and all the advancements will be locked in those companies. And that is true to some extent, but on the other hand, it is actually quite easy to get into machine learning field. There's a lot of open source projects, and you don't need much to start. But ultimately, if you do want to work with the cutting edge models and train them, then sure, you'll need some resources that only large companies have. But yeah, people should not be discouraged. And still a lot of innovation, and most of the innovation comes from academia, right? From PhD students and like undergrad students. And they don't have like access to cutting edge compute and like huge server farms. They're just smart and crafty, and they come up with ways to improve the models.
Fair enough.
There is a whole field of engineering and research that tries to optimize these large models, both for vision and for language, to work better on like more constrained resources. So people came up with you can see actually that with large language models, right? Facebook releases something like Llama, which is a huge model, and then open source community takes the model and quantizes the weights, maybe prunes the network, and they create like much smaller and more efficient models that perform on the same level as large models. So right now, if I want, I can run a Llama model on my laptop, right?
That's amazing. And AI is one of the few sectors that actually is still seeing strong investments by the venture capital community. So hopefully that supports that development too.
That is true, and I like that, although I would say that there is a lot of hype nowadays around it.
Of course.
And I highly doubt that most of these bets will pan out, but I'm happy with the situation.
I'm sure you're very happy. Changing gears a little bit here, ethical considerations are vital in AI development, right? We touched a little bit about bias, but how do you ensure that the AI systems you build are ethically sound and aligned with social values? Do you have perhaps any views on the Chinese room argument as well?
So when it comes to social values and AI, my opinion is that we will have hard time agreeing what those values are, right? Because different cultures and different groups of people have different values, and what we in Japan value might be different than what people in Africa value, right? So I think it will be hard to find like a global set of values that everybody agrees upon. Having said that, we should try to come up with a decent solution for that problem. in when in my previous company, Ascent Robotics, we were building robotic systems for factory automation. So in a way, ethics was not directly our concern. Sure, there is like an ethical impact of like replacing human labor with robots, but that's not directly tied to the machine learning model development, right? When it comes to the future AI systems, especially if we get closer to building artificial general intelligence, then definitely ethics and moral values will become crucial. When it comes to Chinese room argument, that's a bit I would say, separate from ethics, and it's I'm not sure how familiar audience is with the Chinese room argument, but basically the question is, can the automated system really understand and reason, or is it just basically a set of instructions, right? I don't have a strong opinion on it.
Fair enough.
and I do think that the scientific community is still divided when it comes to the answer to that problem. I do think that current large language models are not conscious, and they won't be for the foreseeable future. Although even that is an issue, because I don't think we have a good definition of consciousness in the first place. And do I think that large language models understand the world and language as humans do? I don't. I still believe they just do statistical pattern matching, but who knows? Maybe that's what brain does too.
Well, yes, in an area like, for example, the law and legal advice. The question is, if you've been given legal advice by a computer and it goes wrong, whose fault is it? And and of course, there's a bigger argument behind it.
My opinion about that in a similar context, for example, autonomous vehicles, right? If you're riding in an autonomous vehicle and there is a crash, who is responsible for it? And I think that the provider of the autonomous software should be responsible for that, because I don't see that as any different than if a car suddenly loses its wheel, right? Because of it was built improperly, right? So the car manufacturer is at fault in that situation. The same should be with AVs and autonomous drones and all the other similar systems. If we at some point in the future give human or robot rights to to AI systems, then maybe we should reconsider that. But until then, I think that the company releasing AI product should be responsible for the behavior of that product.
Fair point, Marko. We'll see when we get there, I suppose. Going back a little bit to your managerial experience in the AI space, we touched upon how important it is for teams to work effectively together and efficiently. But I suppose because the projects that you work on could be quite different. Although in your last company it was all about robotics, but there are so many different parts to delivering that solution, that you're dealing with different stakeholders, the data scientists, the developers, the domain experts, your clients. And I think a lot of people still don't have a full understanding of artificial intelligence. So anything that comes out of it could be seen a little bit with some degree of skepticism, perhaps. And so as a manager of a company that is focused on AI, how do you bring all the stakeholders together?
A good question. So machine learning and AI systems are still seen as black boxes, and they are black boxes to some extent. We understand how they operate on a mathematical level, but we don't really know why they produce the results they produce, right? So when you're talking with your customers, you need to always figure out a way how to explain the models and systems to them. Why should they believe that your system is safe and that it will operate properly, right? We had a lot of negotiations around that when we were working on autonomous vehicle projects. Our customer was very concerned with the fact that they don't understand why, for example, a perception or a planning neural network outputs some result, right? So managing that aspect is very important. But then also another important aspect is to manage expectations, because sometimes AI is seen as a magical technology, right? And especially from the perspective of business people that are not very familiar with the capabilities. So they expect way more than what's possible, right? So you have to set the expectations and manage their expectations. And then just building a product, AI product, involves a lot of moving parts, as you said, and machine learning modeling is probably the smallest part of the whole product. For example, in our robotic system, machine learning / AI was used in several components, but the whole solution involves a lot more code and infrastructure than just those couple of machine learning models, right? So it's truly a multidisciplinary effort to build an AI product. Most of the best practices from software engineering and project management apply to machine learning projects and products. You just have that added complexity and uncertainty of machine learning training and data collection.
There's one element of the workflow that interests me particularly, which is the deployment. And when you actually deploy the models in production, it can be quite complex because you go from a lab situation into a real-life situation. Can you describe a little bit some of the common challenges you face during the deployment phase, and how do you tackle that?
Machine learning is specific in that way that you have two distinct phases. One is training the model and building the model, and then the other one is, as you said, like inference and deployment. And the hardware that you use for those two stages can be, and usually is, completely different. So, for example, we would train our neural networks on cloud, on GPUs in some remote servers, but then we will deploy our solution on robots or cars, right? And most of the time you don't want to deploy neural network that's basically defined in code with PyTorch. So most of the time you want to compile the model and preferably also optimize it for the deployment hardware. So if you have some embedded hardware like in robotics or any other edge device, you want to take the neural network that you trained and then optimize the mathematical operations to run efficiently on the deployment hardware. And we have good optimization libraries for that. NVIDIA's TensorRT is one of those solutions, and that's actually what we used extensively in the previous company. As we already mentioned before, that domain drift is something that happens often, where the real life data slowly shifts, and then you need to retrain the model. So having a automated deployment and possibly training pipeline is very important and helps a lot if you don't have to do everything manually all the time, but just build the pipelines. And that's the whole field of machine learning operation, MLOps, which is very important for building good and reproducible models. When it comes to deployment, again, you also want to ensure that you don't have any downtime during the normal operation, but also during the time when you need to, for example, swap the models, right? If you train the new model and you want to swap the one that's in production, you need to ensure that you don't have any downtime. And then, yeah, depending on your actual product, your infrastructure, there are ways to do it, obviously.
Sure, more specialized. Marko, for this last part of the interview and the podcast, I have a bit more personal questions, if you don't mind, about your experience. So let's start with this. You were not originally an AI expert. I mean, you started in a different field in science. And so when you actually went into your AI career, did you encounter any unique or unexpected challenges, and how did you overcome them?
Well, the first challenge that I had to overcome is to start working on it.
Fair
So
enough.
I mentioned that I'm from Serbia, and that's where I started my career. And yeah, at the time there was no machine learning and AI available basically in Serbia. So the first challenge was, okay, I need to move out, to go somewhere else, and find that work and learn also, right? So that was the first challenge. Good thing about machine learning and programming is that you can do it on your own. Yeah, it definitely helps if you're surrounded with the right people and you have discussions and learn from them. But if you're motivated and hardworking, nothing is stopping you from actually studying on your own and getting good at it. So that was that was a huge problem to solve at the beginning. Then I had to catch up with the field, right? Learn the necessary math, learn the necessary programming, and then once you enter the workforce and start working on the projects, you learn on the job. I think that one thing that people entering the field should do is work on their personal projects if they have time, and they should make time for it, and also make them public. So I think that personal portfolio is very important nowadays.
Understood. Marko, can you share with us some real-world use cases where you've worked on projects with AI that have made a substantial positive impact in whatever way you want to measure it?
I don't think I can measure a positive impact, but I do think that one of my favorite projects so far was definitely building the robotics automation solution at Ascent, because we developed that solution from 0 to 1, from basically an empty whiteboard to a robot working in a factory, integrated into a factory. And it was a very complicated project that consists of both AI and non-AI components. It took us a while to develop it, to debug it, to perfect it. So yeah, I think that was so far that has been my favorite project.
In your experience as CTO of an AI company, what advice do you have for aspiring AI developers who want to pursue a similar career?
Try to work on your personal project if you have time. If you don't have time, try to make it. I know it's sometimes hard and there's a lot of other things to do, but I think it helps a lot in the career, because you want to work on the visibility. People need to see your work, to see how good you are, and that will help a lot in your career. Never stop learning, so there's always new stuff to learn, new development. So try to uh, stay up to date with the research and new tech, and just do good work.
Fair enough. And learn Python.
uh, sure, but I think that nowadays you could probably, well, no, I retract that. You should know Python if you want to do machine learning.
Fair enough. Where do you see the future of artificial intelligence heading, and what are some of the exciting trends or breakthroughs that you think are going to happen in this field for the next few years?
That is very hard to predict, and I think that anyone who has who makes these predictions is making them without any substantial evidence.
Maybe more of a wish.
Yeah, well, it would be great if we have the AGI systems that are aligned with us and can automate a lot of the nasty and boring work that we do. And I do think that's coming at some point. How close we are to that, I'm not sure. Some people believe that we'll have it in 2-3 years. Some people believe that it will be 20, 30, or maybe even longer. Yeah, I don't want to give any prediction.
Fair enough.
But I don't think that we will have artificial general superintelligence in the next 2 or 3 years. I think that's premature, and we still need some fundamental breakthroughs. But who knows? I might be wrong.
Well, we'll have another episode of the podcast in a couple of years with you, and then we see. And last question, Marko. Can you share any personal AI projects or research interests that you're currently working on or you're planning to explore in the future?
Yeah. So right now I'm engaged in building something new, so that I can't yet disclose. But I'm also working on a side project, a small side project, which is kind of fun. It involves finance, actually, which is your domain. So
fantastic.
So there was recently there was a research paper from University of Florida, and a couple of researchers basically built a system where they ask ChatGPT to predict stock prices, right? And at least in their paper, ChatGPT was able to do it fairly well. And so I'm replicating that, but only for Bitcoin. In a couple of days or maybe a week or two, there will be a website where you go and it will tell you what ChatGPT thinks about the Bitcoin based on the news from the day prior, right? So the system scans for the news articles about Bitcoin and related topics. It analyzes all those articles and then forms an opinion on how the price will go up or down or stay neutral. Obviously, I wouldn't trust it. It's not a financial advice, but it's fun to make it and just post it online.
That sounds great. I look forward to that. Marko, thank you so much for your time. It's been amazing hearing your insights into the world of artificial intelligence and working in it. And thank you very much for your time.
Thank you. It was my pleasure.
Well, folks, this is the end of the episode. I hope you've gained interesting insights if you're ever interested in a career as an artificial intelligence or machine learning engineer. Marko was a great guest, and wish you all a great day. Stay cool, stay positive.